Before solving this question, let's go ahead and take a look at what it's actually asking us. We're asked if non-negative integers n and p are not both odd, which of the following must be odd? So before we actually dive in, and the typical way to kind of go about this problem would be maybe to pick numbers and rule out answer choices. But before we do that, we actually want to take a look at the answer choices that they actually offer us. The key word being in the question, we're asked specifically which of the following must be odd. So we want to actually recall what it means for a number to be odd. For a number to be odd, it means that we have the structure of 2 times n plus 1, where n is actually some integer. Let's actually use something other than n. Let's use n tilde just because we have n's going on here as well, so we don't want to confuse those. So this is just kind of the structure of what it means to be odd. So if a number is odd, that means it's always going to have this structure. This piece being an even number and then plus 1. So every odd number could be split into an even number plus 1. So that's going to be the structure that we're looking for when we look at our answer choices, because we need that the answer to be must be odd. So before we actually dive in and pick values for our n and our p that satisfy our question, we always want to check out the answer choices to see if any of the answer choices stand out having this structure automatically. We can't rule out ones that don't because we're not really sure, but n times p doesn't necessarily have this structure. Neither does n times p plus 2. 2n plus p, if p was 1, it'd definitely be odd, or if p is any other odd number, this whole thing would be odd, but since we don't know exactly what p is, it doesn't necessarily have this structure yet. 2 times n plus p, that's actually automatically even. So that's something to notice. If the question asked us what's must be even, that would stand out. But this one right here, this actually stands out kind of matching this form. If n plus p ends up being an integer, then we have the structure for a number that is odd, 2 times an integer plus 1. So n plus p, if that's an integer, and we're told that each of them are non-negative integers, so the sum of them must be an integer, that means that this structure is always going to give us an odd number, no matter what n and p are. So that means we don't actually have to choose numbers for n or p. We already know our answer choice. This answer choice E must be odd, and it's regardless of what n and p are. Now we could arrive at the same exact answer choice if we had picked numbers, and we might have to pick a couple values of n and p. But with these types of questions that ask us which must be odd or which must be even, a lot of times we can find the answer choice by just looking at the actual choices that they give us for the answers and not having to go through that whole process. So our final answer is answer choice E, 2 times n plus p plus 1.